In the last part of this lecture, we looked at parabolas in standard form, which is f of x equals ax squared plus bx plus c. Now we're going to look at quadratic functions of the form f of x equals a times quantity x minus h squared plus k. These are quadratic functions that are in vertex form. So we graph these pretty much the same way as we did the previous ones. So for example, if we take f of x equals negative 2 times quantity x minus 3 squared plus 8, the first thing we need to do is determine whether it opens up or down. And we do this by looking at a, which is the number in front of the parentheses. So in this case, a equals a negative 2, so the parabola opens down. Now, we need to determine the vertex. Well, this is the nice thing about vertex form of the parabola, or a quadratic equation. We know that the formula is hk, where the 3 and the 8 are, and hk are the coordinates of the vertex. Now, if we go back to the formula up at the top of the page, it says x minus h. So since we have x minus 3, our h is actually a positive 3. And our k is, since it's plus k in the formula, our k is a positive 8. So our vertex is at 3, 8. The next thing, of course, is our axis of symmetry. So the axis of symmetry is a vertical line that has the equation x equals the x-coordinate of the vertex. So that's 3. Now let's find the intercept, the y-intercept. So we plug in 0 for x, and we get negative 2 times, in parentheses, 0 minus 3, square the parentheses, plus 8, which is negative 2 times a negative 3 squared plus 8. Negative 3 squared is 9, and negative 2 times 9 is negative 18. So a negative 18 plus 8 gives us a negative 10. So our y-intercept is 0, negative 10. For the x-intercepts, we solve f of x equals 0. So negative 2 times x minus 3 squared plus 8 equals 0. So the first thing we're going to do is subtract negative 8 from both, subtract 8 from both sides, which is a negative 2 times x minus 3 whole thing squared, and then that equals a negative 8. Now we need to divide both sides by negative 2, which leaves us with an x minus 3 squared equals a positive 4. Now we're going to use the square root property. So we take the square root of both sides, and that gives us x minus 3 equals, now remember, when we take the square root, because we have a variable involved, we have plus or minus 2. So either x minus 3 equals a positive 2, or x minus 3 equals a negative 2. Then we just add 3 to both sides on both equations, and we're left with x is positive 5 or x is positive 1. So our x-intercepts are 5, 0, and 1, 0. Now all we have to do is graph what we know. So we know that our vertex is at 3, 8. So let's plot that point. We know the axis of symmetry is a vertical line through the vertex. So we can mark it on there. We know that our y-intercept is at negative 10. And because of symmetry, we also have a point the same distance away from the axis of symmetry on the other side of it, which is at 6, negative 10. And our x-intercepts are at 1, 0, and 5, 0. And now all we have to do is draw our parabola. Okay, pretend I went through the points. Okay, the domain, just like with every parabola, since it keeps getting wider and wider and wider, is negative infinity to infinity. The range is negative infinity to the largest point it gets is a y value of 8. Now, there's another example on the next page, so pause the video and you try to do it before you watch my solution. Okay, hopefully you paused the video and tried this on your own so you can compare. So the first thing we need is whether or not the parabola opens up or down. Well, there's an implied 1 in front of our parentheses, so A equals 1, which means the parabola opens up. Okay, our vertex, remember, is HK, and so our H in this case is a negative 2 because we have a plus 2 here, but remember the formula says x minus h. So this would have to be minus a negative 2 to get the plus 2. And our k is a positive 1. Okay, the axis of symmetry is a vertical line that passes through the x-coordinate of the vertex. So that's at x equals negative 2. Then we need our y-intercept. So we plug 0 in for x, and we get 0 plus 2, quantity squared, plus 1. Which equals 4 plus 1, or 5. So our y-intercept is at the point 0, 5. And now we need to find our x-intercepts. So we have x plus 2, whole thing squared, plus 1 equals 0. So first we need to subtract 1 from both sides. And that leaves us with x plus 2 quantity squared equals a negative 1. Now we'll take the square root of both sides using the square root principle. So x plus 2 equals the square root of negative 1. This, the square root of negative 1, is imaginary. And we're graphing in real numbers, so that means there is no X-intercept. So, let's graph what we know. Our vertex is at negative 2, 1. Our y-intercept is at 0, 5. Our axis of symmetry is a vertical line through the vertex. And since we know the point 0, 5 by the symmetry, if we go to the same spot on the other side and put another point, we now have 3, and we can graph our parabola. Okay, the domain, just like with all parabolas, is negative infinity to positive infinity. And the range, the smallest it is a positive 1, and it goes all the way to infinity. There's one more part to this section, and it will be on another video.